Today we are going in depth more about glycolysis process. Okay. First step is phosphorylation. Phosphorylation of glucose is catalyzed by enzyme hexokinase. A phosphate group is transferred from ATP to glucose, forming glucose 6-phosphate. Isomerization. Glucose 6-phosphate is rearranged to be converted to its isomer, forming fructose 6-phosphate. Step 3 is phosphorylation. Phosphorylation of fructose 6-phosphate is catalyzed by phosphofructokinase, and then a phosphate group is transferred from ATP to fructose 6-phosphate, forming fructose 1,6-bisphosphate. Step 4 is splitting. Fructose 1,6-bisphosphate will be split into two 3C molecules. The first one is dihydroxyacetone and the second one is glyceraldehyde 3-phosphate. 5 is isomerization. Dihydroxyacetone phosphate is rearranged to convert to its isomer, forming glyceraldehyde 3-phosphate. This is because the next enzyme in glycolysis uses only glyceraldehyde 3-phosphate as its substrate. So, there are two molecules of glyceraldehyde 3-phosphate molecule produced. 6 is oxidation and phosphorylation. Oxidation of glyceraldehyde 3-phosphate will reduce NAD+ to NADH plus H+. And in phosphorylation, inorganic phosphate from cytosol will combine with glyceraldehyde 3-phosphate, forming 1,3-bisphosphoglycerate. 7th step is substrate level phosphorylation. 1,3-bisphosphoglycerate is converted to 3-phosphoglycerate. Enzyme transfer a phosphate group from 1,3-bisphosphoglycerate to ADP, forming ATP. Step 8 is isomerization. 3-phosphoglycerate is rearranged to forming 2-phosphoglycerate. Step 9 is dehydration. Water molecule is removed from 2-phosphoglycerate, forming phosphoenol pyruvate, which is PEP. The last step is substrate level phosphorylation. Phosphoenol pyruvate is converted to pyruvate. Enzyme transfer a phosphate group from phosphoenol pyruvate to ADP, forming ATP.
Now let's go through a question. So first step is glucose will undergo phosphorylation to form glucose 6-phosphate, and this glucose 6-phosphate will undergo isomerization to form fructose 6-phosphate, and then fructose 6-phosphate will undergo phosphorylation to form fructose 1,6-bisphosphate, and this fructose 1,6-bisphosphate will undergo splitting to form two molecules of 3-carbon, which is dihydroxyacetone phosphate and glyceraldehyde phosphate, and this dihydroxyacetone phosphate will undergo isomerization. Glyceraldehyde 3-phosphate will undergo oxidation and phosphorylation to form 1,3-bisphosphoglycerate. And then this 1,3-bisphosphoglycerate will undergo substrate level phosphorylation to form 3-phosphoglycerate. And then this 3-phosphoglycerate will undergo isomerization to form 3,2-phosphoglycerate. And then this 2-phosphoglycerate will undergo dehydration to form phosphoenol pyruvate. And then this phosphoenol pyruvate will undergo substrate level phosphorylation to form pyruvate. And that will be the last step for this glycolysis.